Okay, it's 10 o'clock, so I'm going to start. Today is a little bit of an odd day. I'm going to start lecturing on Chapter 6, just because I don't want us to fall behind. We missed a snow day earlier on, so we're a little bit behind, and I don't want to sacrifice that. But I do want to spend much of the day today doing sort of a review. We'll do a little review here in class, and then we will do a practical over in the lab today, which I think will be a real learning experience for most of you. And I hope you'll enjoy that. I think you will. Basically, everyone in the class will set up a station, and then we'll lay the questions down, and you guys will all rotate around. No pressure, not going to be graded. The answers will be on the back of the little cards that'll be laying there, so you can look at them. But it'll probably give you an idea of kind of where you stand as far as your studying is concerned and so forth. It'll also show you the mechanics of doing a practical exam for those of you who have never had a practical exam before. Okay? But before we get crazy on all that stuff, I'm going to talk for about 40 minutes or so. So when the big hand gets to the 8, somebody stop me. And we'll stop there and do this review thing I've got in mind. Okay? Now, so far, if you think about it, we've covered kind of the general orientation of the body and what A&P is all about. Chapter 2 was about chemistry. Chapter 3 was about cells. Chapter 4 was about tissues. And now we're starting through the organ systems. We've done one, we've done the integumentary or skin system. The next one we're going to do is going to be the skeletal system. Indeed, the entire second test in A&P here, 231, will be on the skeletal system. So before we really get into the bones, let's talk about what bone is and how bone is put together, how it's formed, what are the chemical reactions involved, and so forth. This is a picture of my dog and my wife. And it's time for Miss Frizzle to get out the bones. I think one of the things about this part of A&P is there's probably no part of A&P which is more tactile, that you get to feel stuff anymore. And we have 6 boxes of bones, one for each table. Over there, we have 6 skulls, and we will learn all the parts of all the bones, basically. Now, that's not really true because there's a lot of stuff I eliminate for you, but you'll have a very good familiarity with every bone in the body. And so I would continue to remind you that continually look at the skeletons that are in the room, look at your bones, and feel on yourself, feel your bones. Because all those things will really help you put this whole thing together. The skeletal system, which is what we're talking about, includes just a few things. It just includes the bones. There's 206 of them, I think. I don't care about numbers. It also talks about the cartilages, ligaments, and the connective tissues. Before we get to the end of this chapter, we will discuss the joints, the articulations. We basically eliminate most of the joints, and I just kind of like you to learn about the shoulder joint and the knee joint. I think those are the most important ones, and if you know those, they have all of the characteristics that you see in the other joints, and we just don't have time to go through every one of them. So what are the functions of the skeletal system? Well, clearly the first one is support. It holds us up. Without bones, we would be a blob of soft tissue laying on the floor, kind of wallowing around, which wouldn't work very well. It also stores minerals for us, mainly calcium and phosphorus. We'll learn about those a lot. The bones also store some lipids, fat. Now, the bone marrow, which is the middle part of the bones, is usually red marrow. And if you've eaten a chicken bone and you finish the chicken leg and then you break it, you can suck the bone marrow out if you're really hungry. It's high in protein and pretty good stuff. As we get older and later in life, a lot of our red marrow turns into yellow marrow and fills up with fat. And we're going to talk a lot about little old ladies and their bones and osteoporosis and all that stuff, and that certainly is part of the issue. The bones become much weaker as we get older. It was not unusual in our hospital out in the Dalles for half of the people in the hospital to be in there with broken hips and broken femurs and so forth. It's a really common problem in America, especially in the elderly. More women than men, we'll talk about all of that. But anyway, protection. Function of the skeletal system is protection. Your chest bones clearly protect your heart and lungs. Your skull bones can protect your brain. And so that's where that comes from. And then finally, leverage. Our muscles, for example, our biceps muscle is a muscle here that is attached to your humerus. This is your humerus, your arm bone. Attaches up here, and then the tendon of the biceps, you can feel it right here, and it goes across the elbow joint and plugs in right there to the radius. And so when this muscle here contracts, it pulls on your radius and makes your arm flex. And so clearly without bones, we couldn't move. So that's a major function of the skeletal system, is it gives something for the muscles to attach to so that we can walk and run and stand up and move and all that stuff. Those are the functions of the skeletal system. We will learn them in detail. Bones are classified by shape, internal tissue organization, and bone markings. We're going to talk about a lot of these things. Let me tell you that I think this is one of the silliest classifications in the world. But since everybody uses it, you kind of have to know a few things about it. Clearly, this is a vertebrae here, and it's called an irregular bone. Well, I would beg to differ and say that all of these bones are pretty irregular. They're funny shaped. There's not any of them that are perfect squares or perfect circles or any. So really, they're all irregular. Some of them are long. They're classified as long bones if they're a lot longer than they are wide. But once again, some of the long bones aren't really so long. These finger bones down here are classified as long bones, but yet they're not very long. Bones in your skull are very flat. They're thin. They form the skull. I'll just leave them at that. One classification that you should know, and this is called the sesamoid bones. And in the humans, the only sesamoid bone we really have is called our patella, or our kneecap. Now, the definition of a sesamoid bone you ought to know. A sesamoid bone is a bone that is formed within the tendon of a muscle. So, if you think about your quadriceps muscle, which is these big four muscles here on the front of your thigh, they all come together and form the patellar tendon. And they're going to come around here and they're going to implant right there in the tibia, the big bone of the lower leg. And so when the quad contracts, it's going to pull your leg out and kick. But basically that's a very important movement in walking and running. So, but because it's going around the knee, it has formed a kind of a lever point there called the patellar bone, which is formed in the tendon of the quadriceps, and we call it the kneecap. We'll see it in lab and so forth. That's the only sesamoid bone we have. One time I was teaching middle school and I ran over a raccoon driving home out in the Dalles, and I got out, threw the raccoon in the back of the truck. I figured I'm going to be really cool. I'm going to take this raccoon and process it, and I'm going to take all the bones and create a skeleton for my class. I thought, well, that'll be easy. So I took the coon and I threw him out in the yard, in the chicken yard actually, and put a piece of fence chicken mesh over him so that he could just dissolve and rot away, you know. And he 3 months later, there's nothing but some fur and a bunch of bones. But I will tell you that in a raccoon, they probably have 30 sesamoid bones. There was more bones in that damn pile of bones than I could ever figure out. So that whole project kind of got washed away. But the fact of the matter is a lot of animals have lots of sesamoid bones, bones that are built into their tendons. Short bones, this is silly. Carpal bones, those are your wrist bones. Clearly your vertebrae are irregular, but we'll talk about them in great length. And sutural bones are really useless. You don't have to know any of them because we don't assign names to them, but sometimes when the sutures form in the skull, they form around a little piece of bone, which really creates a separate bone, and we call that a sutural bone, but it really is of no consequence whatsoever. This always freaks students out at the very beginning until you start getting the bones in your hand and studying them. Bones have lots of little depressions or grooves along the surface. They have little projections or little outpouchings or sticky outy things, I call them. Where tendons and ligaments attach. Usually your tendons are attached to a pointy thing. Sometimes it's not very pointy, but at least it's a bulge out there. And so that's something we'll learn about. There are tunnels. There are holes in the bone where blood and nerves go into the bones. And you see, this is a freak-out slide. Which shows you there's things like processes and ramuses and trochanters and tuberosities and tubercles and crests and lines and spines and heads and necks and it sounds overwhelming, but it's really not. Once we'll just go through them one by one, and you'll figure those out. Here's a kind of an introduction to those terms that kind of look like this. This is your femur. The femur is your thigh bone connected to your hip bone, connected to your leg bone. And the femur is the biggest bone in your body. It's also the strongest bone in your body. And it's the one bone in your body that you can break your femur and bleed to death. You can bleed to death inside your leg from a fractured femur. They bleed a lot, especially if you break both of them. But femur has a head, it has a neck, it has these big bulges here called trochanters. The trochanters are what your hip muscles attach to make you move your hip in different directions. Down at the far end, there's tubercles, which are bulges on the side, which also muscles are attached to that pull your leg one way or the other. There is a facet, F-A-C-E-T is a word you're going to hear a lot. Facet means a smooth area or a joint where two bones rub up against each other. The facets are always covered with cartilage and in a joint. So that's your knee joint, obviously. Condyles is another bulge. I think I don't want to beat this up very much right now. The skull bones, a number of them have sinuses in them. You guys have all had stuffed up sinuses before. Sinuses, there's about four sets of them, I think, in your head. Normally they're full of air. When you get a stuffed up nose, that just means they got a little infection up there or irritations. About half, most of them are from allergies. Some of them are from true infections, and the sinuses fill up with pus, and then you're creating all this green snot, and you got a cold or you got an infection. Sinuses are basically there to make the bones lighter, and they're also there so that when you talk, your voice sounds better. If we didn't have any sinuses and we didn't run the air by our sinuses, we would sound really odd. Think of the sinuses like the box on a guitar. Okay? When you strum a guitar, the reason it makes such a nice sound is because it has that box where the sound can kind of vibrate around in before it comes out, gets louder. Same with our sinuses and our voice. Electric guitars, if you've ever strummed an electric guitar that's not hooked up to an amplifier, it's kind of a tinny, pointy sound. Really, it's very quiet too because it has no vibrating sound box like a sinus. I think that's enough said about all this. Over here, here's half of a hip bone shown. There's a crest. Crest is the top edge. There's a fossa. Fossa is a sunken portion. Spine. There are several spines. There are pointy things. There are lines, which we will learn the name of some of them on the bones. There are different ramuses. A ramus is a projection of the bone. So this is the pubic ramus. This is the ischial rectus. This is part of the pubic ramus here too. So forth. Let's talk about the organization of a long bone. We spend a fair amount of time talking about how long bones form. Remember that most of your bones are formed as cartilage. So little babies have very few bones at all. That's why it's so hard to break the bone of a child. And when people do get a fractured bone in a kid, you always think child abuse, because it's very hard to break a bone in a child. So you'll see a lot in your careers, you will see a lot of social workers in the emergency room usually doing investigations when nurses see a kid with a broken bone and the story doesn't really match up. He fell out of bed, it was a first, it wasn't a bunk bed or something, and broke his femur. That doesn't make sense. So you call social services and they interview the kid and they interview the family. Sometimes you take x-rays of the entire body of the child just to see if they have a bunch of broken bones, because oftentimes you'll find that they've already had 5 or 6 other broken bones that have healed on their own without being reported. The terrible part of society, and by the way, every one of you, whether you're an x-ray tech or you're a nurse or whatever you decide to become, you will be what's called a mandatory reporter. You have no choice about reporting your suspicion to the social service system of our state. And if you don't report it, you can lose your license. In fact, you probably will. So mandatory reporting is very much required of each of us. If you see something, you've got to say something. And then you don't have to make a decision on it. They make all the decisions, but you have to report it. So just know what you're getting into a little bit here. Structures of, did somebody have a hand up?
Well, I was just going to say, little kids, though, they do break their bones sometimes on their own.
They sure do.
Besides them,
I'm not pointing fingers here. I'm just saying that it's very tough to break a bone in a kid. And you got to think about it.
My friend, one of my best friends, her nephew, they're like 2 years apart, I think. And the older one threw it, I think it was a truck at the little one and ended up breaking his femur.
Well, if you've got a good story, nobody's going to arrest you or take your kids away.
But they shall have to talk to a social worker.
Well, sure you do, and it should be. That case should have been reported. And it was, and it sounds like the kids weren't taken out of the home. There wasn't a child abuse report. Nobody was arrested. That's the way the system is supposed to work. But just know that as primary reporters and primary care people, it's part of your license that you have to report any suspicion of that. Same with elder abuse as well. Let's move on here. So the structure of a long bone is really in 3 parts. There's a thing called the diaphysis, which is the shaft of the bone in the middle, and then on either end there is what's called the epiphysis, and then in this area right here where these 2 things meet at each end, this is called the metaphysis. Now, just know that the reason there are those 3 things is because the bone forms in 3 separate parts. The middle portion here is the shaft, and the diaphysis, and it has a heavy layer of compact bone around the outside. The central space is called the marrow cavity or medullary cavity. It's mostly hollow. It has spongy bone in it. We'll see that. And it is where we make our blood cells. It's our bone marrow. The epiphysis is the wide part at each end. These form separately, and they form from cartilage. They are what articulates with other bones. It's mostly spongy bone. We call that cancellous bone, and it's usually covered with a thin layer of compact bone around the outside top. And then there's a little cartilage on top of that, hyaline cartilage, by the way, which articulates with the next bone down. The metaphysis of these places here and here where these things meet, and as you get older and you reach the age of about 25, usually your metaphyses fuse. And at that point, it's all one bone. You'll see what I mean when I show you some x-rays later. So here's an example. This is a femur once again, thigh bone. Diaphysis is the shaft. The metaphysis is at both ends, and the epiphysis is the end on either end. Structures of flat bones. The best example of flat bones are your skull bones. They're very flat. They look like a sandwich. They have a little bit of compact bone on the outside and on the inside, and in between there is some spongy bone. The little bit of spongy bone that lies between the two layers is called the diploe, D-I-P-L-O-E. I don't know why. Diploe 2, it's got two layers, it's stuff in the middle, I don't know. Here's a nice picture, a diagrammatic picture of that, of the skull. And you can see there's a layer of cortex or compact cortical bone on the outsides. There's a layer of spongy bone in between. Bone is a connective tissue. Duh. We talked about connective tissues before, and we said bone, cartilage, blood, tendons, loose or regular tissue. Those are all connective tissues, right? And sure enough, bone is one of them. It's very hard. It's the hardest of all of the parts of the bone of the body, except the enamel of the teeth. It contains very specialized cells. Bone is very specialized. We will talk about the 4 types of cells in bone. And the matrix. And when we say matrix, we're talking about that ground substance, you know, the stuff that's in between in all of these connective tissues. And in bone, that is mostly calcium salts that form the hard parts of the bone when it gets calcified and ossified. But do not forget that there's lots of collagen fibers built into bones as well. Now, you don't think about your bones bending, but believe me, they do. Every bone can bend a certain amount before it breaks, and every bone is supported by a lot of collagen fibers. I think 25%, 30%, somewhere along in there, of a bone is actually collagen fibers. You remember the wide pink fibers that we talked about with the other types of connective tissue? Well, they were built in to that. Let's talk about the characteristics of bone tissue. This is compact bone that we're talking about. So this would be the part of bone on the outside of the long bones, for example. There's a dense matrix between the cells, and that matrix consists of these deposits of calcium salts as well as some collagen fibers in there amongst it. Osteocytes are the bone cells, and I think I've tried hard to get you guys to think in terms of breaking words down. Osteo means bone. Osteocyte means a mature bone cell. An osteocyte is a mature bone cell. It's basically the cells that take care of the bone that lives right around it, okay? And so we'll talk about some others in a second. Canaliculi are these little canals that run through the bone tissue itself. They form little pathways for not only the blood vessels, but also just the cytoplasm of one osteocyte to communicate with the osteocyte, the cytoplasm of the next one. Periosteum. Periosteum means peri means around, and osteum means bone. So periosteum is that very tough layer of dense, irregular connective tissue that is found around every bone. Perichondrium is around cartilage. So it's the tough layer around the outside of cartilage. Now, I think I mentioned to you before that periosteum is the outer layer of bone. So like when you eat that chicken leg and you chewed all the muscle off and then you break it and you kind of pull it apart, there's a stringy kind of tough layer that kind of strings off of it. That's the periosteum. It's on the outside of the bones. Now, it's much, much tougher than what you see when you crack a chicken leg in half, because that's been cooked at 450 degrees for 10 minutes or something and fried. So that periosteum is weakened a great deal. In real life, that stuff is really tough. Most of the bone is calcium phosphate. That's what it looks like, Ca3PO4, 2. And it reacts with calcium hydroxide, forms crystals of calcium hypoxyapatite. I don't want you to learn all that. You don't need to know that. Just know there's a lot of calcium in bone, and these are solid salts that are very firm. Remember, there's also about a third. I said a half, a third, or quarter to a third, but it's about a third. That's the number you should know. About a third of bone is actually protein fibers called collagen. And you know about collagen fibers already. Please know that only about 2% of a bone is actually made up of cells, which means that 90% of it is this other stuff, most of which is the matrix, which is the calcium salts and the collagen fibers that make it strong. All right, so let's talk about the 4 kinds of cells that are found in bone. And they're not very tough to learn. The top one is called an osteoprogenitor cell. What do you think progenitor means? Like a stem cell, like a cell that can turn into a bone cell if it wants to. Okay, that's true. So these are, before they become bone cells, they're called osteoprogenitor cells. They're the immature cells of all. And then they become, if they are going to become an osteocyte, the next thing they become is an osteoblast. And whenever you see the word blast, that always means immature cell, or sort of a maturing cell. And indeed, osteoblasts form the bone. Okay? So anything that's a blast makes a substance. So the chondroblasts make the cartilage that's right around them, and the osteoblasts make the bone that is right around them. Okay? Osteoblast. An osteocyte is a bone cell. We started off talking about that over here. It's basically the mature bone cell. So once that osteoblast has secreted that matrix, has created that layer of calcium salts and collagen around it, then it becomes called an osteocyte. It is a mature bone cell, and all it has to do for the rest of its life is simply take care of that little bit of bone right outside of its membrane all the way around. keep it oxygenated, keep the waste products taken away, bring in new calcium if you're making new bone, and so forth. The last cell, and the only kind of odd one, is called an osteoclast. Now, osteoclasts are very characteristic. You can't miss them. They are big, big cells, and they are the ones that are given the job of eating up bone. So osteoclasts dissolve your bone. So if you're in the later years of your life, your osteoclasts are working overtime. They are chewing away at your bone, and they're taking that bone and dissolving it, and taking that calcium and putting it back into circulation to raise your calcium level. Now, calcium, and I think I've mentioned this to you before, calcium metabolism is one of the most important concepts that we will learn in A&P, because calcium affects almost every process in our body. And so we have very tight controls on the calcium levels in our body. And one of the ways we control the calcium level in our bloodstream, in our body overall, is if we're going to make more bone, and we're activating these osteoblasts and laying down more bone, that is taking calcium out of the bloodstream and putting it into the bone, sort of taking it out of circulation, right? You're making new bone. Osteocytes are keeping it there. And then the osteoclasts, if we need more calcium in our bloodstream, the osteoclasts go to work, and they eat up some bone, freeing up the calcium, letting the calcium float around in the system, and raising your blood level of calcium. So all of these three types of bones here obviously are part of the homeostatic mechanism of maintaining a calcium level. We have a lot more, but just know that that's one of the main jobs here, is to keep our calcium levels just right. Let's go through them one by one, even though I've already talked about them. And I probably said everything. These osteoprogenitor cells are the kind of mesenchymal stem cells. When we say mesenchymal, think immature, a cell that can turn into several different kinds of other things. Stem cells, that's what stem cell means too, can turn into other things. But these osteoprogenital cells can become osteoblasts. Where are they found? Oh, yeah, they're found in the endosteum. What do you think endosteum means? Inside the bone, really on the outside of the marrow. So that inner lining of the bone, right here, is called the endosteum. And what do we call this layer out here? We call that the periosteum on the outside. So, where do these guys really get activated and really go to work? Well, if you break a bone and you've got to build back a bunch of new bone, you're going to want to activate a bunch of osteoprogenitor cells and get them to work laying down new bone to heal the fracture. Okay? The osteoblasts are the ones that secrete the matrix, secrete the calcium phosphate and other salts. That's called osteogenesis. These words are really easy if you just break them down. Osteo, bone, genesis, creation, making bone. Chapter in the first book of the Bible is called Genesis. And what's it about? Making of the earth, the creation. There you go. So, same thing here. Osteoid is this sort of immature matrix that is created at first. It's a bunch of loose chemicals that have not yet added their calcium to form hard bone. So osteoid is kind of like soft bone, and the osteoblasts, once they've made enough of this osteoid, so they're living in a little hole now called a lacunae, a little hole in the bone, then they become osteocytes once they're completely surrounded. Osteocytes live in these lacunae. They're mature cells. They lay it down in layers. I think you guys have already seen bone under the microscope, at least real quickly. You'll learn it a little more in depth now. These cytoplasmic extensions extend out from one cell to the next. Those are called canaliculi. Osteocytes do not divide. One cell doesn't divide to make two. These are mature cells. Their function is basically just to maintain the protein and mineral content of the matrix right around them. And then they can spring back to the life and help repair damaged bone if need be, if you break a bone. Osteoclasts are these eaters. They eat up the bone. They secrete acids and protein digesting enzymes to basically dissolve bone. They are multinucleate big cells, have up to 25 or 30 nuclei in them. They're very obvious under the microscope. They dissolve the bone matrix and release the minerals, basically releasing the calcium. That process is called osteolysis. Bone lysis, in other words, tearing down bone. And it's interesting that these cells here, these osteoclasts, do not come from the same cell line. In other words, they didn't come from osteoblasts or from osteogenitor cells or from osteocytes. They instead came from macrophages. Macrophages are the eater of cells throughout the body, and that's where they came from, because that's what they are. They're the bone eater-uppers. Here's pictures of them. Here's an osteocyte, a mature osteocyte living in its little lacunae here, and that osteocyte there communicates with this next osteocyte over here in the next layer or the next lamellae through these little cytoplasmic extensions which extend through the bone, and they are called canaliculi. Here is an osteoblast. These are immature bone cells. They are secreting the material that the osteoid, and when they have secreted enough osteoid to completely surround themselves, they will mature on to become osteocytes. Here's those osteoprogenitor cells. They're also kind of large cells, but they are uninuclear. They live right on the edge of the medullary cavity, like I said over here, called the endosteum. And then here's an example of an osteoclast, the eater-upper cells. They're very large. They have lots of nuclei in them, and they dissolve bone. So, homeostasis, bone building, and bone recycling must balance. If you're breaking down more than you're building, your bones are getting weaker. If you're creating more bone than you're eating up, your bones are getting stronger. We know of a number of things that will make your bones get stronger, and probably the best one of all is female hormone called estrogen. Works really good. It makes your bones stronger and it prevents osteoporosis. The other thing we know that really works to make your bones stronger is weightlifting or any kind of weight-bearing exercise. Any stress you put on your bone, any weights that you lift, makes your bones grow stronger in preparation for that. Makes sense? So there's no question that exercise, especially weight-bearing exercise, is the best thing you can do for yourself. Now let's talk just a minute about estrogen hormones. When I came to the Dalles, that was 1981. I was this new young surgeon out of the Navy, and I came there and I found that almost every lady in town over the age of 35 or 40 was on estrogen. And it was called HRT, hormone replacement therapy. When you get to be about 35 or 40, especially when you get to be 45 to 50, you ladies kind of start falling apart. No offense, but you kind of do. You don't make enough estrogen, your skin gets dry and saggy, and other things get dry and saggy, and you quit having periods, and you quit ovulating, and your ovaries are kind of going to sleep, and life is just turning to shit. And so what these doctors would do, and all the family doctors in town, these women would come in and complain and say, you know, doctor, having sex hurts these days. Oh, here, you need some estrogen. And it works. Doctor, I'm having these hot flashes. Here, take this estrogen. It works. Doctor, I broke my hip. I think my bones are weak. Here, take this estrogen. It'll make your bones get stronger, and so forth and so on. And damn it, everybody in town was on hormone replacement therapy. It was standard across the country. That's the way we took care of ladies. Somebody said, you know, I wonder if this is all good. Is this a good thing? And so they started this big study through the NIH, the National Institute of Health, and they took like 100,000 ladies, and they gave half of them HRT, hormone replacement therapy, and they gave the other half of them placebo, sugar pills. But they didn't know what they were getting, and the doctors who were giving it to them, they also didn't know what they were getting. And so that's what's called a double-blind study, when neither the patient nor the doctor knows whether you're getting or not. It's to keep all bias out of it. And they found after a while, the guys that were running the study from up in Washington started looking, and they thought, man, a lot of these ladies are dying. And a lot of these ladies are getting breast cancer. And a lot of these ladies are getting uterine cancer, but mostly they're getting heart attacks and strokes. And so they said, I think we need to look and see if it's both groups or if it's all in one group. And come to find out that these huge rates of death were only in the ladies who were taking the estrogen. So although the estrogen makes you feel good, it cures all these other problems because you don't have enough estrogen, it was killing them. They went ahead and broke the study. They told everybody what they were getting, whether they were getting the hormone or whether they were getting sugar pills. And from that day forward, no one in America has gotten HRT because we now know that we were killing thousands, tens of thousands of ladies with HRT. But believe me, you had one very pissed off group of women. And you also had one very pissed off group of husbands when you started taking their estrogen away because they loved it. We also started getting a lot more fractured hips, but because of the calcium metabolism issues as well.
Is there a natural way to reduce estrogen?
Not really. You'll see the ads on TV now. There's some ads for, one of them is for painful sex. You guys have seen those ads. Well, what those are is they have taken the estrogen and taken very, very tiny, tiny amounts and put it in a cream, which then is used inside the vagina. So the lady doesn't get enough estrogen to really affect her whole body. It's just very, very local. It's a tiny, tiny dose. Also, birth control pills have been made smaller and smaller and smaller doses of estrogen, smaller and smaller doses of progesterone to prevent all these issues as well. So we have learned, and it took a huge study because people didn't want to give it up. We've learned that estrogens are pretty rough on folks in the long run. Okay, I'm going to stop there. Slide says homeostasis, and we'll pick up there next, I guess a week from today, next Tuesday. Thursday we have our test. We have a written test in here at 10 o'clock. Let's say boo. Tests are learning experiences. You can learn so much from a test. All right, everybody pull out a piece of paper. I'm not going to take these up, so don't freak out. Question number 1. Number 1, name one organ in the body where you would find pseudostratified ciliated columnar epithelium. One place where you would find pseudostratified ciliated columnar epithelium. Number 2, which layer of the epidermis is found only in thick skin regions?